Welcome to the video on intermolecular forces. This is a problem from your mastering, and for the chapter 4 I'm just going to use the problem straight from mastering, because for the next two problems or the next two videos it's sometimes a problem of being able to submit the answer correctly, and sometimes students get a little bit confused with the instructions and submitting process. The reason this problem is chosen is because it's one of the most missed problems. It kind of incorporates a lot, so it can be difficult for the students. So we're going to look at intermolecular forces. So this is from chapter 5.8, I do believe. Let me check that real quick. And we're talking about hydrogen bonding and dipole-dipole attractions and so forth. So yes, 4.8. So intermolecular means between two molecules. Okay, our dispersion forces are our weakest interactions between nonpolar compounds. So from the list above, we're going to look for our nonpolar compounds. And then dispersion forces and dipole-dipole. So dipole-dipole means we have a polar covalent bond. Okay, so we have a difference in electronegativity, but it is not a hydrogen bond. Okay, if we have hydrogen bonding, it's going to include all of the forces, but also hydrogen bonding. And this is when we have a hydrogen bonded to a nitrogen, an oxygen, or a fluorine. Okay, and so some of this takes into account that you have to know how to draw these molecules, and also you have to know, you may need to use your electronegativity chart as well. Okay, so we're just going to go through these quickly. Okay, the dispersion forces only. These are going to be our nonpolar compounds, and to be nonpolar they're going to have to be nonmetals. Okay, one little hint, I'm not sure if I mentioned this on the video or not, but when you have hydrocarbons, so basically just compounds that contain only hydrogen and carbon, these are always nonpolar. So you can check this by your electronegativity chart if you want to, but the electronegativity value will be less than 0.4. Okay, so if we look up here, it looks like we've got methane, which is a hydrocarbon, and we have this is called propane, which is a hydrocarbon. Okay, and so these are going to be dispersion forces only. Okay, and we'll drag those down here in a few minutes. Okay, now we're looking for dipole-dipole forces. So they're going to have dispersion and attractions as well within them, but they also have dipole-dipole. So we're looking for covalent compounds. So they're going to be nonmetals. Okay, but there's going to be a moderate difference in electronegativity. So these are kind of sometimes harder to spot. Okay, and the one that is a dipole-dipole force is this molecule here. Okay, and some students see the hydrogen and the nitrogen and they think that it is a hydrogen bond. But when we draw this, so if you did the NASB theory, it's going to look like this. So this is actually acetonitrile. And we have the hydrogen is bonded to the carbon, not to the nitrogen. Okay, so a hydrogen bonded to a carbon does not mean that it is a hydrogen bonding attraction. Okay, and so this one's going to be a dipole-dipole force. So if you need to go back and look at the video on drawing Lewis electron dot symbols and structures, or Lewis structures, you may need to do that. Okay, so the remaining two, so process of elimination, these two are going to be our hydrogen bonding. Okay, when we look at ammonia, we've got, this is what it would look like if we when we draw the structure. And so we've got a nitrogen bonded to a hydrogen, and so we would have hydrogen bonding. So if we bonded to another ammonia molecule, we have a partial negative, partial positive. And once again, this is covered in the video 5.8. We have hydrogen bonding, and then we also have methanol. So methanol also has an oxygen bonded to a hydrogen. Okay, and so now if we go back to here, we said that for dispersion only, our hydrocarbons, we had one dipole-dipole because that hydrogen is bonded to the carbon, not to the nitrogen. And then we have hydrogen bonding. And if we submit, we should get the correct. And then when you keep going, it's asking you for boiling points and may even be asking for melting points. But you just want to remember that the stronger the attraction, the higher the boiling point. So the dispersion forces are the weakest, dipole-dipole are next, and then hydrogen bonding is next with respect to nonmetals. Also, ionic bonds, I don't think we include those, but they're the highest, okay? But we're not looking at those. We're just looking at nonmetals. So I hope this helps for this problem in Chapter 4 homework.